Okay, hi. We're going to be talking about absolute value equations today. And if you look at this problem right here, you'll see that it says what two values would make this statement true. And if you start thinking about it, you should be able to in your head realize that if I made s equal 2, then 2 plus 3, right, should give me 5. Well, what's 2 plus 3? The absolute value of 5, which is 5. Likewise, I can think of another number because with absolute values, there's always two answers. And if you want to think about this one, just instead of doing positive, let's go ahead and try to think of a negative number. And right here, we can see that if I put in negative 8 plus 3, the absolute value of it should give me 5. So negative 8 plus 3 is the absolute value of negative 5. And what's the absolute value of negative 5? Just plain old 5. Now this is important to remember with the number-wise because there has to be a math way in order to figure this out. Because we can't always just in our heads assume or figure out what this number is right here. So we come to absolute value equations. Now this one might be a little bit trickier than the example that I just showed you. But what you do, and I have the steps listed right up here, is you're going to have two cases. Just like you had two answers for the previous problem, you're going to have two answers for these as well. Your first case, basically all you do is you write the same exact problem. And then for your second case, you're going to keep what's inside the bar still the same, but you change the sign of the number that's after the equal sign. So instead of positive 10, it's going to be negative 10. And then from there, all you do is just solve your two equations. So you would add 5, so you're going to get 15. Then you're going to divide by 4, so you're going to get 15 over 4. And that is one answer. Same here. If I add 5, I'm going to get negative 5. Then I divide by 4, so I'm going to get negative 5 over 4. And that's my second answer. So that means that if I wanted to substitute this back in for my value of a, whenever I take the absolute value, I should be able to get 10 out as my answer. And it would work. That's just the way you can check yourself. Alright, let's go ahead. We're going to do the third example. We're going to skip down here. So I'm going to have my two cases again. So my first case is negative 5v equals 25 because you keep it the same. The second case is negative 5v equals negative 25 because remember you changed the sign of the last number. Once again, solving for v, 25 divided by negative 5 is going to give me negative 5. Negative 25 divided by negative 5 will give me positive 5. And those are your two answers. Now, sometimes what students assume is that for absolute value equations, it's always going to be a negative and the positive of the same number. That's your answers. That is false. That is not true. Because if you look back at that first example that we did, let me go all the way back, you can see that that actually is not the case. Because here, a was 15 over 4, and then negative 5 over 4. So it just so happened that for this bottom problem, my answer was 5 and negative 5. So don't just assume that. Alright, we're going to move on to solving inequalities with absolute value signs. The same rules apply. You still have your two cases, except for your second case this time, you're actually going to flip the inequality sign as well as change the sign of the number. So your first case is 5x minus 4 greater than 2 because you keep everything the same. Your second case is 5x minus 4. You flip this sign and then you change the sign of this number right here. Okay? So then, just like we did with the other problems, we just solve each problem individually. So I'm going to go ahead, I'm going to add 4, so I get 6. Then if I divide by 5, I get 6 over 5. That's one answer. And then my second problem, if I add 4, then I'm going to have 2, and then I divide by 5, so I get 2/5. And that is my second answer. Now notice though, this means every x that is greater than 6/5. So that could be the number 2, the number 3, the number 4. So it's actually a range of answers. It's not just x is only 6/5. In fact, it's not even equal to 6/5 because that does not say or equal to. It's just every number in the world that's greater than 6/5. Same here with this one. It's every number in the world that's less than 2/5 is an answer. Okay, let's go ahead and look at the second example on there. This one, you really should be able to solve just by inspection. And you have to look and you have to see here, if I was to take the absolute value of any number in the entire world, when would I have an answer or a number, a solution, that would be greater than -12? Well, if you take a second and think about it, every number that you put into an absolute value will always be positive in the end. So how many numbers can you think of that are positive, that are greater than -12? There's infinitely many answers. So problems like this would just be all real solution. Okay, moving on, we're going to do a few more. Here, if I do have this example, I can't go ahead and make my two cases because your absolute value has to be isolated. So you have to get this by itself first. So what I'm going to do is I'm going to isolate just the absolute value. So here I can see this says 7 times the absolute value of n. So the way that I move over the 7 and isolate the absolute value is to do opposite operations. So instead of timesing 7, I'm going to divide by 7. Then I would have the absolute value of n is less than or equal to 8. Now that the absolute value is by itself, I can make my two cases. So my first case is n less than or equal to 8. My second case, n is greater than or equal to -8. And as you can see here, there's really nothing that we need to work for these two cases because the problem's already solved. And that's those are our final answers. Okay, for the next problem, if you want to go ahead and look at it, the absolute value is still not isolated, so I need to do that first before I break my two cases apart. So instead of adding 4, the opposite operation tells me to subtract 4. So then I would have the absolute value of n minus 2 is greater than 1. Okay? And so for this problem right here, you can go ahead and make your two cases because the absolute value is by itself. So n minus 2 greater than 1. N minus 2 is less than -1. Because remember, you flip and then you switch. Solving by adding 2 means we would get n is greater than 3. And then n is less than 1. Okay, our last example is interesting because just by looking at it first, somebody might assume, well, this would be no solution because there's no positive number that would ever be less than -15. But that's false because you can't assume that because you have to work the problem first. And in order to do that, you still have to isolate the absolute value. All right, so if you can see that this -3 is really what needs to be moved over. So since it's times the absolute value, we do the opposite operation, which tells us to divide. So we're going to have the absolute value of 2n minus 5, because this canceled. But anytime you divide by a negative number, when you're solving an inequality, your sign always flips. That's just an algebra rule. So this would actually be right here, instead of less than, greater than 5. Once again, anytime you divide by a negative number with inequalities, you will always flip this sign. Now, please note that when I say divide by a negative number, I'm referring to the number that we divide by to isolate, not this number right here. I do not care that this number is negative whenever it comes to flipping my inequality sign. You only are concerned about the bottom number. All right, and then from here you can make your two cases, which is 2n minus 5 greater than 5. In your second case, 2n minus 5 is less than -5 because you flip and then you switch. And then solving for it, we're going to get 10, and then you're going to get 5. Once again, solving for this one, you're going to get 0, and then that will just leave you with 0. All right, that about does it for solving values or absolute values with inequalities. If you have any questions, you can come by and see me before school.